Hello and welcome back to PNC part 2. Let's get started. Okay, so we're going to be doing a new concept right now. So they've asked us to arrange the word be. So if I say that you can arrange it in two ways, you can move this E here and this E here. This is literally the same word, and in permutations we have to take this, we have to consider this. Okay, so as there are two similar words, so 3 factorial will give us 6 combinations. But in reality, this will only have 3 combinations, which is E, B, E, E, B, and B, E. So as these e's are the same and shuffling them will have no impact, so for that to happen we have to divide it by 2 factorial, which will only leave us with three combinations. So as two are similar, we have to divide by the factorial of that. Okay, so now we're going to be solving some similar questions. Okay, so we've been given the word evermore and we have to arrange it. So if we have to arrange it in 8 letters, we can simply do 8 factorial. But because there are 3 e's same and 2 are same, so we will do upon 3 factorial into 2 factorial. So this will give us 3360. Okay, now if they had asked for example, 4 letter arrangement from the word evermore, so I would have thought, okay, we have to choose 4, 8c4 into 4 factorial. But in this case, I won't know, okay, in how many selections will I have 3 e's, in how many selection I will have 2 e's, in how many selection I will have 2 r's. So I will have to divide it by 3 factorial and 2 factorial respectively, no? So I won't know this, and I can't generally divide everything by 3 factorial and 2 factorial. So this method is wrong. So for us to divide it in 4 letter selections, we have to divide it up. So for example, I say that we can have 3 e's and 1 different, 2 e's and 2 different, 2 e's and 2 r's, 2 r's and 2 different, and then 4 different. Alright, these are all the possible arrangements that are possible. Okay, now we have to first of all select all of these and then we can arrange them. So for 3 e's we have we use 3c3 because we're choosing all of them, and 1 different, so we can have 1 2 3 4, any of the 4, so 4c1. Okay, now 2 e's, so 3c2 into 2 different, so again any 2 of the from the 4. Okay, 2 e's, so 3c2 into 2c2, this is a 3. Okay, now 2 r's, 2c2 and 2 different, so 1 2 3 4, any 4, 2 from the 4, and 4 different, so you can have 1 2 3 4 5, any 4 from the 5. Okay, now we have to arrange all of these, so we do 4 factorial for each and every one of them. Okay, but in this case we have 3 e's same, so we will divide it by 3 factorial. In this we have 2 e's same, we will divide it by 2 factorial. In this we have 2 e's and 2 r's same, so we will divide it by 2 factorial into 2 factorial. In this we have 2 r's same, so we will divide it by 2 factorial. In this we have nothing similar, so we won't divide it by anything. Then we will take out the result of each and every one of these and we will add it up. So the result of all of these 1 2 3 4 and 5 things will be the number of 4 letter selections we can have from the word evermore without any repeating. Okay, now let's move forward. Okay, so now we have the pegs question. So in the pegs question, we have 4 spaces for a peg to be placed. Okay, now there are 6 pegs, all of different colors, and we have to arrange them. So we can do 6c4 into 4 factorial. So we're basically picking 4 of them and then arranging them in 4 and shuffling them in 4 factorial ways. So now 4 pegs consisting of 2 blue, 1 red and 1 yellow. So again, this time we only have 4, so 4 factorial, but because 2 of them are same, so divided by 2 factorial. So this will give us 12. Okay, now 12 pegs of 2 red, 2 black, 2 blue, 2 orange, 2 green and 2 yellow are placed, and we have to arrange 4 different colors. So this is very simple. We have 6 different type of pegs and we have to choose 4 of them, and they can be arranged in 4 factorial ways, which is equal to 360. Okay, now let's move forward to the next part of this question. Okay, so in this they say 3 different colors. So what people normally do is 3 different color means that two are of the same color and one is of different color and another one is of a different color. So what you do here is you select one of them to have 2 pegs, and then you select 2 of them to have 1 peg, and then you can shuffle them in 4 factorial ways, but because 2 of them are same, you divide it by 2 factorial. Okay, so now let's look at the fourth part. So this says that any of the 12 pegs. So for any of the 12 pegs, we can have all 2 same, 2 different colors, 2 same, 2 same colors, and all 4 different colors. So for 2 same and 2 different, we just did this in question is in part 3. It's 6c1 into 5c2 into 4 factorial upon 2 factorial. In 2 same, we select 2 from the 6, and then we do 4 factorial upon 2 factorial into 2 factorial because 2 of them are same. And then in 4 different, we simply select 4 from the colors, and because none of them are same, we do 4 factorial. So you add all of these up and you will get your answer. Okay, now let's move to the minibus question. Okay, so in this question, there is a minibus consisting of 7 total seats and we have 11 passengers. So now first of all we have to find the possible arrangements for the 17 passengers. So 17C11 and then 11 factorial ways they can sit in. Okay, now let's move at the second part of the question. So possible arrangements in 5 particular people go in the back. So 5C5, choosing all of the 5, they can sit in 5 factorial ways, and the remaining 12 seats can place any of the 6 people. So they can sit in 6 factorial ways. So this will give you your answer, which is 7.9 into 10 to the power 7. Okay, now let's look at part 3. Alright, so in this part they say that of the 11 passengers, 5 were unmarried and 6 consist of 3 married couples. In how many ways can 5 of the 11 passengers be chosen if 2 married couples and 1 other person? Okay, so the 1 person can either be married or unmarried. So first of all we have to choose through 2 married couples. So we have 3 married couples, we choose 2 of them. And then we have to choose 1 from any of the 7 remaining passengers, included the 1 married couple. Okay, and we have to choose them. The question says chosen, so we don't have to arrange them. So this equals 21 and this is the answer. Okay, now let's move to the aeroplane question. Okay, so this is the aeroplane question. So we have 14 seats and 12 passengers. So first of all, how many possible arrangements are there for 12 people? So 14C12 into 12 factorial. That will give you 4.35 into 10 to the power 10. Okay, now 12 of the passengers consist of 2 married couples, 5 students and 3 businessmen. The 3 businessmen people sit in the front row. The 5 students sit at a window seat. Mr. and Mrs. Lin sit in the same row, and on the same side of the aisle, and Mr. and Mrs. Brown sit in another row, but they sit together on the same side of the aisle. So how many possible seating arrangements are there? Okay, so first of all, let's look at the three businessmen. So there are only 3 seats in the front row. So all of the 3 rows are being all of the 3 seats are being occupied, and they can sit in 3 factorial ways. Okay, now let's look at Mr. and Mrs. Lin. Now they can sit in any of the 3 couple seats. There are 1, 2, and 3 seats for couples. So they can sit in any of the 3 seats, and they can sit in 2 factorial ways because there are 2 people. They can sit either like this, Mr. and Mrs., or they can sit like this, Mrs. and Mr. Okay, so this is Mr. and Mrs. Lin. Now Mr. and Mrs. Brown sit in another row. So they can, if you suppose that these 3 rows are being filled, if these 3 seats are being filled, and Mr. and Mrs. Lin sit here, so Mr. and Mrs. Brown can sit from any one of these 2 seats. So they sit in any of the 2 seats, and they can also sit in 2 factorial ways. So now they've occupied, for example, this seat. So that leaves us with 1, 2, 3, 4, 5 window seats. So only 5 window seats are left. So 5 into 5 factorial, because the 5 students sit in 5 window seats. So this question is probably the most tricky question in the math syllabus, and the answer is 17280. Okay, now let's move forward to the third part of this question. So in the third part, instead the 12 passengers are seated randomly. Okay, now find the probability that Mrs. Lin sits directly behind a student, okay, and Mrs. Brown sits in the front row. Okay, so now let's see. Let me copy the diagram here. Okay, so if Mrs. Brown sits in the front row, she can sit in any of the 3 places. So 3C1, which is equals to 3. Okay, and now Mrs. Lin has to sit behind an empty seat, so a student can sit in front of her. So let's suppose that Mrs. Brown sat here. So that leaves 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 seats in which Mrs. Lin could sit for an empty seat to be in front. Okay, now she sat in 10 seats. Now in the seat in front of her, any of the 5 children can sit. So 10 into 5. So that leaves us with the 9 people other than them. So, and 11 seats, so they can sit in 9 factorial ways in the 11 seats. This gives us 2.9 into 10 to the power 9. Okay, so now we have to find the probability of this happening. So this happens in this many occurrences. So let's take it as the numerator, and in the denominator, let's take if the seating happened in a random manner in all 12 factorial ways. So this gives us the answer 25 upon 364, which is the probability of this condition happening. Okay, so that was all from permutations and combinations. I would advise you to do as many questions as you can, because this is a subject. This is a topic which you understand from doing the questions. Thank you for watching. Goodbye.